Alright, so let's go through the 12 of 10 2020 H2 Physics AC question. So we have this AC power supply connected to 3 resistor, right? So we have 12, 6 and 12 ohms, right, in this figure. So we are also given the relation with time of the voltage of the power supply given by this expression as shown. So we got V equal to 9 sine 120 pi t. So of course you all still remember the expression is given to be as such. V equal to V naught, where this V naught is your peak voltage, and then sine 120 pi. So 120 pi itself, right, is your omega right here, and of course the T. Okay, for the very first part, we are asked to determine what is the power supply. I mean the frequency of the power supply. So just remember, this 120 pi is omega, meaning 2 pi f equal to 120 pi. So cancel this, cancel this. Then after that, your f is just equal to 60 hertz. So that's the very first part. Okay, what about the second part? Second part is also simple. The root mean square of your voltage. So it's your V RMS equal to V naught over square root 2. So you just use 9, where 9 is the peak voltage right here, divided by square root 2. Because it's a sine wave, so that's why you can use the V naught over square root 2. Okay, let's move on to the next part. So part 2, we are asked to calculate the peak current from the power supply. So we know one thing is that my VRMS, meaning my so-called like EMF like that, right? So it's about 6.36 volts. So of course, if you do the calculation for the total resistance for the parallel part, it's just 4 ohms using the 1 over R equal to 1 over R1 plus 1 over R2. Of course, eventually you need to flip it, so you should be able to get about about 4 ohms. So of course, this is the 12 ohms, this is the 4 ohm, right? You add together, so this will give you 16 ohm. So in turn, right, you can actually calculate your I. R equal to V over I. So your I that you are calculating is your IRMS, the root mean square current. So meaning this one is the resistance to be 16. So the V is the VRMS. Always remember, for AC is all about RMS. So it's 6.36. Of course, the IRMS is equal to 6.36 divide by 16. So it's about 0.3975 ampere. So that is your root mean square current. But they want us to calculate what is the peak current. So peak current very simple as well. So IRMS is equal to I naught over root 2. So just multiply them together. So meaning the IRMS is the 0.3975 multiplied by square root 2. So it's about peak current I naught, right, is about 0.562 ampere. So that is the answer for this part. Okay, so the next part, the last part will be calculate the mean power dissipated in the resistor of about resistance of 6 ohm. Okay, so mean power, always remember, is this. So mean power, of course you can also think of it as the RMS power, but they will not phrase it as RMS power because it's a bit weird. So mean power is equal to V RMS multiplied by I RMS. Okay, so let's go back to the so-called the circuit, right? So we are asked to determine what is the so-called mean powers. Mean power that is dissipated by this 6 ohm. Very simple. So first, we actually calculated the IRMS already. So meaning that so my IRMS is given as such, 0.3975. So let me just write down 0.3975 ampere. So this is the total, so-called like total current like that, right? So it's going to flow through like that. And of course, don't forget, when you reach this junction, it's going to split up. But it's not going to split up equally. It's going to split up in some ratio, right? And what is the ratio? So you look at the first branch is 6 ohms. The second branch is 12 ohms. Meaning that the current that's going to flow through the first branch will be twice as much as it is going to flow through the second branch, because current like to flow through the path of least resistance. So just think of it as this is 2 units, this is 1 unit. So in turn, right, so total 3 units represent your 0.3975 ampere. So of course, what is 1 unit? 1 unit you simply just divide. So 0.3975 divided by 3 is about 0.1325 ampere. So because you want the current that's flowing through the 6 ohms, right? So it just times 2. 2 units is equal to times 2. So it's about 0.265 ampere. So 0.265 ampere, of course this is your IRMS. It's going to flow through the 6 ohm resistance. So in turn, of course, what is the average power? Average power is given to be as I RMS square multiplied by R. So you just sub in. So for example, this is 6, right? So this is I square. So you just square the 0.265 square. So this will give you 0.265 square times 6. Okay, so the so-called mean power, right, is about 0.42135, which is as good as saying 0.421 watts. So that is how we actually do the last part, 0.421 watts, right? So that is how we do this question.